Good morning, students. Section 3.6 is what we're working on today. It's more linear equations. We're just going to be working with number problems and consecutive integers. So let's begin with what do we mean by number problems and consecutive integers? Well, they're going to be like a word problem, and you're going to have to write it from an English phrase into a mathematical equation and then solve it. And so let's begin with the basic, like, what's the best way to approach those? So we're going to solve word problems involving translating number phrases and consecutive integers. So a four-step process for solving problems. One, understand the problem. What are they asking me? Read it carefully. Be sure that you understand all the terms. Maybe you circle the important words. Write out what those words mean. Then you're going to devise a plan. Maybe you set up a table or something that you'll carry out your plan, and then once you've completed and look back over your results, test it to see if what you did worked. So here we go. Here's our first word problem. 3 times the sum of a number and 5 is equal to twice the number plus 5. So I'm going to go through here. Sum, the word sum right here tells me I am going to be adding. The word a number is a variable. I'll just put X there, and 5. The sum of a number and 5. That would look like this. And then it says 3 times the sum of a number. So I need to put a 3 out in front of it. It's equal to, so the is and the equal. Twice, what does twice mean? Multiply by 2. Twice the number plus 5. So here is our equation. That is what we're going to work. And I kind of had to look, what did twice mean? What did the sum mean? Number and 5. 3 times, I'm noticing I'm not 3 timesing the number, I'm 3 timesing the sum of the number and 5. So that's why it looks like that. And it gives us a distribution that we're going to have to work and do later on, doesn't it? Okay, so now let's go ahead and work that problem. First, let the unnumber be the unknown variable. So 3 times the sum of a number and 5 is equal to twice the number plus 5, and we put those together. And now we're going to solve. I'll subtract 2x from each side, and I'll subtract 15 from each side. And I get x equals a negative 10. And then I can check that the number is a negative 10. And I could say, does that work for 3 times a number plus 5? A negative 10 plus 5 is negative 5. 3 times 5 is a negative 15. And 2 times the number, a negative 5, is negative 10 plus a negative 5. So yeah, it works, just looking at it. If a number is decreased, what does decreased mean? It means subtraction. By 36. So 36 is going to be second. And a number, that's my x. The result is also the same way you say it is. There's our is, equals 76 less than. So that means I'm going to subtract. This is also going to take a second place position. Twice the number. Here's the number again. Whatever number we used here, it's going to go here, so x. And then it asks us what is x. So let's do this. A number is decreased by 36. So we're going to let x be the number, and we're going to decrease it by 36. And it says the result is 76 less than. So I'm going to put the 76 in the second place position, less than, twice the number. And there is my equation. So now I think I'm going to move my x's to the right, and I'm going to add 76 to each side. And I get 40 over here. And then I'm going to move my x's to the left. So I'll subtract x from each side. And x equals 40. And so we should get 4 for the answer on both sides, which we do. And so that would be the correct way of going about that. Let's go ahead and watch it through. They used n. Is it okay that we used x? Absolutely. Unless they specify that what the variable should be, you can use whatever. I like to save n for when I'm doing consecutive numbers. Okay, one integer is 4 more than 3 times the second integer. So we're dealing with two numbers. Okay, the first integer, if it's x, the second one is 4 more than 3 times the second integer. Their sum is 24. So what are the two integers? If we let the first one be x, then the other one integer, is 4 more than 3 times a second integer. So let's see. I don't want to use x and y because I need to use the same thing. Let n be the second integer, then 3n plus 4 is the first integer. That's how we want to do it. That's right. If n is the second one, then the first one is 4 more than 3 times the other integer. And their sum is 24. So this one plus this one equals 24. So n plus 3n plus 4 equals 24, or 4n plus 4 equals 24. Subtract 4 from each side. 4n equals 20. Divide 4 by each side, and n equals 5. So the first number is 5. What is the second one? Well, we plug it into here, and we get 5. 3 times 5 is 15. 15 plus 4 is 9. So our two integers that we're looking for are 5 and 19. And I did need two integers. When we go back to that original problem, what are the two integers? So I'm looking for two answers, okay? Okay, Joey pays $300 per month to rent an apartment. If this is 2/5 of his income, what is his monthly income? So 2/5 of his income equals, it says it's 2/5 of his monthly income is his rent, and his rent is $300. So we could rewrite that as 2/5 of some kind of variable equals 300. Now, if we wanted to solve for that, we're just going to turn these by 5/2, aren't we? And we get 5 times 150 for our answer there. Let me erase this. And that's $750. So he makes $750 a month, and he pays $300 a month. I don't know where he lives, in some imaginary land, because I don't know where you could do that anymore. Maybe when you're at college and you're sharing a room with 6 other people. So there you go. Okay, we're going to take a minute just to understand the word consecutive. Consecutive means one right after the other. If I had a number line and I put the number 3, what is the next consecutive number? It's the number right after it. So it would be 4. And then what would be the next consecutive number after that? 5. And the next consecutive would be 6. So 3, 4, 5, 6. So what if we don't know where we start, though, on the number line? Well, let's do it this way. Let's say we do know we start at 3. The next number is how many away? 1. So if we start at 3, then our next number is 3 plus 1 away. And if we start at 3 again, and the next number after that is 3 plus 2 away. And then the next number after that would be 3 plus 3 away. Well, that's just really 3, 4, 5, 6, and those are the consecutive numbers. So you notice wherever you start, the next one is plus 1. The one after that is plus 2 from the original starting point. The one after that is plus 3 from the original starting point. And you can imagine how it goes on plus 4, plus 5, plus 6. And so when we think of consecutive numbers, the first three of our consecutive numbers are always going to start out as n plus 1, and n plus 2. If we needed to have 4 consecutive numbers, our next one would be n plus 4. So that's how consecutive numbers work. Now, sometimes in life we count by twos. We count 1, 3, 5, 7, 9. Those are called consecutive odd integers. Okay. And so let's look at a number line for that. Let's say that we started here again at 3. What's the next odd integer? Now we're looking at just odds, right? So there's 4. 5 is the next odd, right? So it's how many away? 1, 2. So the starting was 3 plus 2 got us to the next number, which was 5. And then away from that, the next one would be 7. So starting at 3, that's 1, 2, 3, 4, or the starting point plus 4. Well, now what if we didn't know where we started? Let's say we started at n. The next one away is still going to be 2 away. And the next one out after that from the original starting point is going to be 4. And what would you say the next one would be? N plus 6. And the next one after that, n plus 8, and so forth. So 1, 2, 3, 4, 5. Those are the first 5 consecutive odd integers. And when you're working with a word problem, please be careful and look for that word odd or even, okay? So let's look at even numbers. How does that change if they're even? Well, let's draw our number line again. This time we're going to start at 2 because it's an even number. The next even number away is 4, but that happens to be how many hops away? 2. So if we started at 2, then the next number is 2 plus 2. And if we wanted to go to the next one, which is 6, we would actually go 1, 2, 3, 4 away. So 2 plus 4. So just like odds, even numbers work the same way. Our next one would be n plus 6. And our next one would be n plus 8. And so forth. So this is the thing that if I were doing a card that I could use to study or look at during my test, I would probably have a little chart that did this on it. And I would say consecutive numbers. And then I would be like first, second, third, so I could show how the pattern worked. The first one would be n, the next one would be n plus 1, and the next one would be n plus 2. And then maybe in this chart, I would have a little segment over here, consecutive numbers that are odd or even would be n, n plus 2, n plus 4, so that I remembered that's how I should do them. Okay, so let's look at a couple problems. 3 numbers, important to know, consecutive, odd. So that means I'm going to be using the n plus 2, and n plus 4. And those are the first 3, aren't they? First, second, and third. That's my 3 numbers. The first one is always n. It's our starting point. The second one is 2 away. And the third one is 4 away. It says, are such that their sum, if I add them together, first plus second plus third, their sum is going to equal a -3. Now, important here, they're integers. That means I should have no fractional or decimal numbers when I'm done. They should be whole numbers or their opposites. So the first one is really n. The second one is n plus 2. And the third one is n plus 4. And they're going to equal -3. So I collect like terms over here. I get 3n plus 6 equals a -3. If I subtract 6 from each side, I get 3n equals a -9. Wait, I'm gonna, yeah, subtract 6. Okay, and then n equals a -3. Is 3 odd? Yes. What would be the next one on a number line? -3, hop 2. I'm actually at a -1. Don't ever go to the left with these. You always go to the right, okay? So I'm actually, my next one would be -3. My n plus 2 would equal a -1, and my n plus 4 would equal 1. And so my numbers are a -3, -1, and 1. And those are 3 consecutive odd integers that when I add them together, their sum is a -3. And that actually is true, isn't it? -3 plus a -1 plus 1 is a -3. All right, just a quick look at how they set it up. They did it just like we did. They wrote it out a little bit more. Solve it first, second, third. And there's our 3 numbers. And make sure you have 3 numbers. They checked it. There. Oh, yep, it works out. Okay, so here we go. Find 3 consecutive integers. Does it say odd or even? No. It just says that I'm looking for 3 and they're consecutive. So I'm looking for n plus 1, and n plus 2. Those are my 3 numbers. First, second, and third. Such that the sum of the first and third, well, first and the third is 76 less than, that's going to go in the second place position, 3 times the second. Well, 3 times the second is n plus 1. So I've got collecting like terms over here, 2n plus 2. A distribution over here, 3n plus 3 minus 76. I can collect these like terms. So I have 2n plus 2 equals 3n minus 73. I think I'm going to add 73 to each side. And I'm going to get 2n equals 75. Oops, sorry. 2n plus 75 equals 3n. So subtract 2n from each side, and 75 equals n. My first number is 75. 75 plus 1 more is 76. And 75 plus 2 more is 77. The sum of the first and third, 75 and 77, is 76 less than 3 times the second. So we could check that out. And let's see what they do. They're going to check it for us, I'm pretty sure. And they do. And they are equal, so good. Find 3 consecutive even. So here we have consecutive, but they're even. Now, it didn't matter if they were even and odd. They're still going to be n plus 2, and n plus 4, aren't they? Such that the 3 times the first, so 3 times the first is 10 more, so I'm going to add 10 to it, than the sum of the second and third. That's 2n plus 6 plus 10, 3n over here. That's 2n plus 16, 3n. Subtract 2n from each side. I get n equals 16. So I'd have an even number of 16. The next even number would be 16 plus 2 is 18. And the next even number would be 20. And so those would be my 3 numbers. We multiply that. There we go. And they're going to check it for us. And that is the end. So please make sure in your notes somewhere that you have written down what it means to be consecutive, and then consecutive, odd, and even, and make sure that that appears somewhere on your card for when you take a test or a quiz so that you can refer to it quickly. Hopefully you have a great rest of the day. Good luck in Derivata. There will be some consecutive number problems to work with, so good luck on that. And if you have any questions, just call me or text me. Thanks. Bye.